welcome again to Lost in Science across Australia on the Community Radio Network. This is half an hour where we talk all about things scientific. Now, you may have heard us talk about bees over the years on this show, and there's been all sorts of dire warnings about the decline of bees all over the planet. One of the things that is a threat to bees is a tiny little parasitic mite called the Varroa mite, which until fairly recently was actually not present in Australia, so our honeybees were quite safe from that particular threat to their health. Recently, near the port of Newcastle in New South Wales, there was an outbreak of Varroa mite. The Varroa mite was detected in hives around the Newcastle area, and action was taken to try and control that invasive species at the point of entry. So this week on the show, Claire has been talking to an expert in bee ecology, Dr. J. Iwasaki from the University of Adelaide, who spoke to her all about Varroa mites and what threat they pose to the European honeybee in Australia. So please stay tuned to hear all about that particular worrying topic and the rest of Claire's interview.
Congratulations on your discovery, which may well prove to be among the most significant in the history of science.
I cannot accept half-baked theories that sell newspapers. I'm a scientist.
Who are you, who are so wise in the ways of science?
A most distinguished scientist, whose name we know, even in the wild of Transylvania.
Across Australia on the Community Radio Network, you are listening to Lost in Science.
The discovery of the parasitic Varroa mite in New South Wales that preys on honeybees has sent Australia into somewhat of a bee lockdown, as drastic measures have been taken to try and contain this biosecurity risk as much as possible anyway. We've seen hives across New South Wales being destroyed, and, this very well might not be enough to keep this killer parasite from spreading. Now, our guest today is Dr. J. Iwasaki, who is a bee ecologist from the University of Adelaide and can answer all my questions I have on the Varroa mite and what this outbreak means for bees in Australia. Jay, welcome to Lost in Science.
Thank you. It's good to be here.
So as bee expert, mites might not be your area of expertise, but can you tell us a little bit about what you know about what the Varroa mite is?
Sure. So yeah, I'm primarily an entomologist, and there's actually a big distinction in invertebrate circles about the mite people. But so mites are arachnids, and the Varroa mite is a very small they used to think it was a hemolymph, which is like bee blood sucking parasite, but it feeds on the fat bodies, which are fat-rich areas of larval honeybees. And as it does this, it basically is a tiny little vampire that can also transmit some harmful viruses like the deformed wing virus. And they replicate inside a cell. Then they will emerge with the newly adult bee and spread throughout the colony like that.
Right. So the Varroa mite is really affecting the larval stages of the honeybee, is it?
Yes, primarily. That's where it does most of its feeding.
Right. And is this virus that you're talking about, is that the main sort of adverse effect that it has on the European honeybee? Like what do we see once there's an infestation of mites in a hive?
Well, the main thing is the mites just replicate out of control, and they can take down a healthy hive, and then in conjunction with viruses, they can make it even worse for if the hive was struggling. The Varroa mites on their own can take down a hive, but in conjunction with the viruses that they also spread, they can do a lot more damage. And those viruses have the potential to spread into native bee populations, but that's not very well understood yet.
Right. And what do we know, I guess, about how these mites have spread into the European honeybee? Have they always been, part of the ecosystem with, where European honeybees are native, I guess Europe, or is this a new parasite?
So Varroa was thought to have changed hosts from the Asian honeybee about 50 years ago and spread throughout Europe and infected most commercial and hobbyist beekeeping operations, and then spread throughout the world after that. In the United States and Canada, they invaded around the 80s just from natural movements of commercial beekeeping shipments. Hives are moved around the world, bees are moved around the world, queens are sent abroad. And until about 2000, Australia and New Zealand were the last beekeeping countries that did not have Varroa mite. And then they invaded New Zealand, which I wrote a paper on the biosecurity implications and the course of action that was taken in New Zealand back in 2015 during my PhD at the University of Otago. And in terms of what New Zealand could have done about it, it's pretty much the same effects that all other beekeeping countries have seen. It's very hard to eradicate, and once it's there, if you don't catch it early enough, it'll establish itself within commercial colonies and into the feral bees that have escaped into the environment.
That's probably a good place to bring it back to where we are currently in New South Wales, which is I guess you would call it an outbreak. There's been Varroa mites that have been found originally in Newcastle, in hives in Newcastle, and potentially spread further afield. What do we know about this outbreak? What measures have been taken to contain it? And interesting to hear your thoughts, especially in relation to what you've seen and researched around New Zealand.
So as far as whether or not they're going to establish in Australia, I think it's still too early to say. The Department of Primary Industries in New South Wales seems to have caught it. I think they're saying within a few months of potentially escaping from most likely a container ship. There are a few accidental introductions at ports in Queensland and Victoria, and it's usually by hives that have accidentally established on commercial shipping, and they just kind of hang out on the ship until it reaches a port, and then make it, of course they need to get some floral resources, so they get off the ship. And
so is this so not necessarily a commercial hive, but an accidental hive that's established on a ship?
Yeah, so bees around the world are always swarming and looking for new cavities to make a new hive in. And sometimes at a port, there's lots of nooks and crannies for them. And they'll find a container to establish a new colony, or maybe there's just like a good porthole on a ship that is just the right size, and they don't realize their mistake until they have no flowers available for a while.
I was about to say that's certainly one thing that you don't see at sea is
yeah, exactly.
Fields of flowers. Right. Okay. Wow. That's fascinating. So that's potentially how it started spreading, and so we've seen sort of quarantine areas and destruction of hives around New South Wales. Is that sort of standard process?
Yeah, so in the previous incursions that were caught pretty early, because the ports have sentinel beehives out, they check them regularly to see if there's any pests that have been introduced, because it's usually the most likely point of contact. And once they detect those bees that have Varroa, they have protocols that have been established for decades. The biosecurity area set up a zone where they try to eradicate all the hives, because it's very difficult sometimes to tell if a hive is infested. So if you have one hive that's infested in an area, it's safest to, if you want to eradicate it completely from Australia, make sure that you take everything out of that area and have movement control so that it doesn't accidentally spread out of that area that you know it's present.
And how, I mean, I guess, you know, they don't know how long it's been since the mites were introduced. But how far can, you know, bees fly and sort of spread these mites?
So one good thing that's working in favor of eradication right now is that it's cold and rainy, and it's not the early spring season when hives typically reproduce and split and go off and abscond from a hive into the wild, potentially carrying these mites. So in the meantime, most infestations will probably be within an apiary of a commercial colony and not yet likely spreading out into the wild. Bees do have a tendency to accidentally enter the wrong hive or to rob honey from feral colonies, for example.
Also something I didn't know. Thank you for letting me know that. That's excellent.
That's right. Yeah, when they put when they put hives out in the almonds, they often have to have many types of variations of color patterns on the hive so that the bees can find their way. Yeah, they're not that smart. They get mixed up. They get confused, and then they can accidentally carry any diseases and mites into another colony where they probably will get accepted, but could be killed off and removed, or into a feral colony that's been established out in the wild, and then you have bigger problems because you don't necessarily know where every beehive in the bush would be, and it's very hard to find them when they're at the tops of trees, for example.
I think we're lost.
We're not lost.
Not even any short-range radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
Well, so far.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
You are listening to Lost in Science across Australia on the Community Radio Network. We are now going to go back for part 2 of Claire's interview with Dr. J. Iwasaki about Varroa mite outbreak in Australia.
So the next steps, I guess we've got destruction of certain hives within New South Wales, which is, devastating for apiarists and farmers, and then restriction of movement between states. That's sort of the quarantine setting. But I'm also interested to sort of hear about, I guess, how the Varroa mite could potentially affect non-European bees, so native bees. Are there well-known effects for native bees, or do we not have a great understanding of it, or potentially some positive effects?
Yeah, so honeybees are just one species of about 20,000 species of bee. And in Australia alone, there's over 2,000. And not all of them make honey. Very few of them actually are social species. The majority of them are solitary. And they all use the same resources, pollen and nectar. So honeybees as an introduced species in very large concentrations in the wild as ferals and in commercial apiaries can consume huge amounts of pollen and nectar that are now not going to our native bees. And that also is big impact on the birds and marsupials that are nectar feeders, which in Australia are a relatively large proportion of the native species. So I've been working on a review paper that looks at the impacts of introduced and managed bees. And while there are some conflicting information or competitive effects that may only be apparent in certain situations, for the majority of studies, honeybees are a big competitor for resources for against native species usually, and have the potential to introduce diseases into those populations as well.
So do we know whether the Varroa mite would impact them?
So Varroa only affects honeybees, which is good. Other bees have their own parasites, but for honeybees, Varroa is one of the most devastating parasites. And in terms of resistance, I think the honeybee populations in Australia don't have much going for them. They haven't been exposed to them before. And those sort of resistances include hygienic behaviors, where the bees will take steps to clean these mites off their bodies and remove them from the hive. Some bees, especially some European honeybees, especially in Asia and Russia, do have those hygienic behaviors that bee breeders are trying to introduce into commercial colonies, but you have actually a trade-off between certain behaviors and other behaviors. So some of those hygienic behaviors may result in bees that produce less honey, for example.
Right.
So that's a very long-term process.
Right. Oh, that's fascinating. So where to from here? I mean, can Australia continue to be this sort of like last holdout without the Varroa mite? Can we, hopefully, fingers crossed and touching wood, this doesn't spread further than it already has with the Varroa mite. Are there things that we can learn from other countries, and like you say, the cleaning behaviours that we can take on board?
So Australia's so far been pretty lucky, and I think part of that luck is good planning, because having sentinel hives at ports is how they've caught Varroa several times before. And in New Zealand, it was thought that Varroa had been present in the country for about 3 years, at least 3 years, and that's gave plenty of time for it to spread through feral populations of honeybees and made eradication probably impossible, although it would have been economically a good choice. And it took about 20 years for the entire country to be overrun, because they had another geographic barrier with the North and South Islands. So I think it took about 8 years to actually get to the South Island and slip through some of the biosecurity protocols. In Australia, it's going to be something that keeps happening. There'll always be these introductions. And if caught early, within probably 6 months, there's a good chance. But once it's established, there's probably no going back. There's not geographic barriers that can protect, maybe except for WA. No, there's plenty of trees that feral hives will spread these mites all the way across as far as they can go. And in other countries, this has been something they've had to deal with. And they usually use miticide strips. So it's a pesticide infused strip that goes inside a colony, and it kills the mites, not all of them, but most of them, and prevents that hive from being completely overrun with these mites. And then they have to reapply. But in the meantime, you have to take careful steps so that your honey doesn't get contaminated. There's much more labor involved in making sure that you're monitoring the levels of mites, not using too much pesticide, because in other countries now as well, where they've been having pesticides to control these mites, the mites are developing resistances. So you've got to come up with new formulations, just like any other pest. In the meantime, though, it seems to be a situation where in the next few months, we'll be able to really know if that's the situation, or, we got lucky and we'll just have to wait for the next infestation.
And Jay, just thinking about, I guess, the role that the honeybee plays, the European honeybee plays in agriculture. It's an incredibly important pollinator. Worst case scenario, Varroa kills off a lot of these pollinators. What are our alternative pollinators, and what should we be doing now to promote them?
Yeah, so while honeybees are super important pollinators, they aren't native, and we have so many other species that could be used with a little bit of investment. So honeybees are really easy. We've known how to take care of them for hundreds of years. We can move them around. We can predict what they're going to do in terms of their swarming behavior and kind of manipulate that. But it's so risky to put all your eggs in one basket.
Bees in one basket, I prefer.
Right. And just rely on one pollinator that could be at risk from an outbreak of disease. Our lab at the University of Adelaide, in Katja Hogendoorn's lab, has been working on what other native bees can be used for pollinating agricultural crops, and in a way that you don't always have to manage them. So if you provide the habitat and provide the food and increase those local native bee populations, then you can, many of them already visit agricultural crops. And by boosting their populations, you can increase your diversity of pollinators and reduce your reliance on just one honeybee that actually costs quite a bit of money to move around and maintain for these different crops, such as apple and almonds and cherries.
So this is potentially something that farmers could be looking into and starting to, plant out certain natives now.
Exactly. So we have an idea of which native bees use which flowers, and a lot of eucalyptus are their preferred species, but they will visit other things because eucalyptus aren't always available. And some of those native bees will visit crops. We know that from some of our surveys, and taking steps to encourage those species in terms of the type of nesting habitat they use, and using the right kind of floral resources, replantings, reducing habitat clearing. Those can make a more robust pollinator community that can actually be providing those services more than they already do. In some of our apple orchards, native bees can make up between 9 and 30% of all floral visitors, so it can actually be quite significant.
And Jay, I've heard of some particular native bee species that they produce honey. Most of our native bees don't produce honey, I understand. So is there sort of like a market for native bee honey that we could be potentially growing?
Absolutely, yeah. So especially from mid-level, mid-coast of New South Wales up to Queensland, you can have native stingless bees in small hives, and they do produce honey that is quite expensive because they only make relatively small quantities, but it is an Australian honey that tastes quite different from European honeybees. I think at the moment it's a bit of a boutique product, but if these bees, which are also excellent pollinators of a lot of crops, have more of a role to play, then absolutely it's a big market that probably could be a niche export as well.
Well, Jay, thank you so much for sharing your bee knowledge, and also giving us an insight into our incredibly diverse and amazing native bees that we don't think of when we think of sort of like, bees in peril, but there are we've got thousands and thousands of native bees out there as well that can be used as pollinators and of course honey makers. It sounds delicious. So thank you so much again, and fingers crossed for this outbreak, and it doesn't spread any further. Thanks again, Jay.
Yeah, it's a pleasure. Thank you.
Australia on the Community Radio Network. You're listening to Lost in Science.
Honey Power by My Bloody Valentine. And that is all we have time for this week on Lost in Science. Thank you for joining us in Getting Lost. If you have any questions or suggestions for the team, get in touch with us by email. We are lostinsci@gmail.com. You can send cheap tweets to us at LostInScience1 on Twitter, or you can find us on the ubiquitous Facebook. Lost in Science is recorded at the studios of 3CR in Melbourne on the land of the Kulin Nation and is broadcast across Australia on the Community Radio Network with the assistance of the Community Broadcasting Foundation. You can find a podcast version of the show on 3cr.org.au, or you can tune in the way you did this week when we return in our usual time slot to get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.